Okay, we're going to get started again on our next agenda item, and we will be hearing from two speakers. The first is Jill Johnston, who received her PhD in Environmental Sciences and Engineering from the University of North Carolina at Chapel Hill, and is currently an Associate Professor of Population and Public Health Sciences and Director of the Environmental Justice Research Lab, excuse me, in the Division of Environmental Health at the University of Southern California. She conducts community-driven studies and exposure assessments to address inequitable exposures to harmful contaminants that affect health disparities, including in Latinx, Black, and Asian Pacific Islander communities and among the working poor. She has studied health impacts of oil production in Los Angeles and South Texas and has served on technical advisory panels on health impacts of oil production for the LA County Department of Public Health and the state of California. Today, she'll be presenting on urban oil drilling, environmental justice, and community concerns.
Thank you very much, and thank you for the invitation to be here today. All right, are my slides up? Yeah, awesome. Great, so I'm just going to share a broad overview, really focused around community concerns and ongoing research around upstream oil and gas extraction, with a focus on Los Angeles County. So I have no conflicts to disclose. And so just bringing us back kind of over a century, there was a massive oil boom in Los Angeles. The oil was easy to access, close to the surface, and there was a rampant proliferation of wells that soon followed its discovery. The laws that govern both the ownership of land and oil in early 20th century California really encouraged this dense rush drilling. And the results are really that this kind of industrial development and extraction was intermingled with where people were living and where businesses were operating. And this really kind of exemplified a pattern of development where these industrial operations were occurring alongside where people were living. So today there are over 20,000 active, idle, or abandoned wells spread across the county of 10 million people. While only about 10 to 15% of these wells remain active today, LA is still one of the largest urban oil fields globally. In addition to extraction, like this comes along with a massive network of pipelines, refineries, and cars and trucks that burn fossil fuels daily. And largely, this industry has been underregulated, and there are very few requirements that have separated where this is occurring from where people are living. Instead, sort of in lieu of strong regulations, and in response to some land use conflicts, really the response was voluntary efforts that intentionally tried to disguise the oil and gas operations that were happening in these urban areas. So what this looks like is the pictures here where oil wells were operating inside buildings in these Disney-like islands just offshore or integrated into parking lots and strip malls. And so this was really coined aesthetic mitigation technology, or really it's just hidden in plain sight. Another popular practice we see at these wells that tries to disguise its operation is the use of industrial masking odorants. So these are kind of perfume-like compounds that try to mask other noxious smells, such as hydrogen sulfide. And the protections that we see at different communities really depends on who lives in that nearby community. And so about 15 years ago, there was a rapid increase in oil production, particularly in some wells in South LA in the Las Ciénegas oil field. And this uptick in the production resulted in communities experiencing a lot of nosebleeds, malodors, headaches, wheezing, and it was that community organizing that finally realized that hidden behind this wall was 23 oil wells. This was a largely low-income, predominantly Mexican and Central American community, And really kind of the health efforts around understanding the impacts of these oil wells started with this community. And illustrated here is just examples of them kind of using mannequins to illustrate a lot of the experiences that were happening when this upswing in oil production was happening. This was largely ignored by many regulatory agencies, and the community was really asked to provide stronger proof or scientific evidence that there was a connection between oil drilling and community health issues. Particularly in this community, the EPA came to visit this site in late 2013. Many of the inspectors got ill, and since then this site has been idle, but there are several nearby in the neighborhoods that continue to operate. And so what we find in Los Angeles is really this unmatched proximity to these oil drilling sites. Here we kind of illustrate how close the nearest residential building is to an oil drilling site. And in the vast majority of cases, there's less than 500 meters that separate the operations. There's about 2,500 active and 2,500 idle wells that still are operating or could operate across the county. And the majority of these wells are concentrated in predominantly people of color communities. And so we know this sort of can amplify and compound many impacts faced by those communities. And so to understand more about the potential cumulative burden and the impacts of oil and gas drilling in LA County, we compared CalEnviroScreen scores to proximity to oil and gas wells. Here we generated quintiles specifically for LA County, and with that associated the proximity to oil wells, or whether or not there was an oil well within 1 kilometer, to the quintile of the CalEnviroScreen score. So in essence, we observed that there was about a 94% increased odds of being within 1 kilometer of a well among the highest quintile compared to the lowest quintile in LA County. And when we looked at multivariate models, the proportion of Black residents and the higher quintiles of CES scores were also associated with significant odds of having an oil or gas nearby. And so with this, we can see that there is sort of several environmental justice implications when we look at the locations of these operations in LA County. So when speaking to the community, they also bring up several cumulative burdens that they face from the existence of these wells. So for example, many people bring up not only odors, but also extensive truck traffic, damage to the roads, and this is addition to being sort of near freeways, near truck corridors, as well as having less access to educational or healthcare resources. And the health effects that are frequently brought up include these acute health symptoms such as runny nose and nosebleeds, headache and dizziness, eyes, throat, and skin irritation, as well as adverse impacts to pregnancy outcome and increased wheezing and asthma. Also, folks often talk about concerns related to carcinogens and the use of carcinogenic compounds at these sites. And as you can see with these two pictures in South LA, we see how close they are located to residential buildings and to schools. And so just to highlight a few of some key health impacts that we've seen when specifically looking at communities near these South LA drill sites, that we have found adverse impact to respiratory health as well as cardiovascular health among residents that live within 1 kilometer of 2 drill sites in South LA. So in this study specifically, we recruited almost 1,000 people in partnership with community-based organization and community health workers or promotoras to complete a questionnaire, conduct spirometry, as well as do blood pressure measurements. And so kind of high-level overview, we found that proximity to oil drilling was significantly associated with lower lung function. And we saw the largest deficits among folks that live both nearby, so about less than 200 meters, and downwind from the oil wells. And the impact we saw was similar to studies that found adverse impacts to living with someone who was a smoker. And we saw this impact across all age groups and as well as among asthmatics and non-asthmatics, affecting that we see harm across sort of multiple populations in these communities. Similarly, we also found significant decreases in blood pressure as the distance from the site increased. So this suggesting that we're also seeing adverse impacts to the cardiovascular system. And this primary data that we collected from South LA really builds upon a much larger body of literature that shows increased risks of adverse birth effects, especially preterm birth, and respiratory outcomes in communities near upstream oil and gas drilling. And so in addition, we have done some community air monitoring using gas sensors in these same South LA neighborhoods. And there we observe higher methane concentrations near oil and gas sites, as well as spikes of non-methane hydrocarbons, especially when there's activity happening at the drill pad. Additionally, we have observed significant decrease in air pollution as wells go idle. So as wells stop producing, we see decreases in both methane and non-methane hydrocarbons, as well as if we look at specific chemicals such as benzene and toluene. And when we look at a source apportionment analysis, we can observe that a natural gas drilling source, when the well was active, contributed about 25% to all the VOCs we observed in the neighborhood, and less than 1% once the well went idle. So this suggests that the drilling activity does matter for air quality, even in these communities that are near freeways and other sources of air pollution. And so finally, this is some very preliminary work that we've done among residents that live within 1 kilometer from active oil wells. And we measured toxic metal concentrations in toenails. So here we've measured manganese, cadmium, lead, antimony, arsenic, and nickel, mercury. And so this is kind of very early work with about 250 people, but with that we use these similar source apportionment techniques and kind of identified 3 distinct factors. One of them, which may be associated with oil drilling, and that factor contains manganese and nickel levels. We're working kind of on a larger study with this, including people that are farther away from the drill site to kind of understand more of these potential associations. And so kind of with that, I'm happy to take questions and just want to acknowledge kind of the many folks that helped to make some of this work possible. Thank you.
Thank you. We have a few minutes for questions specific to this talk before we go on to the next one. Sure.
Thank you very much, Dr. Johnson. My name is Nancy Biermeyer. I'm with the Breast Cancer Prevention Partners. And I've heard people talk about the perfumes that are pumped into the world around these wells. And we do a lot on fragrance and all of the toxic chemicals in fragrance. And I was curious if any of the air monitoring was able to focus specifically on those perfumes, or if there's a way to get a sample of those perfumes in particular to see if we could figure out what's going on with those. But thank you overall for all the work you're doing. It's awesome.
Yeah, thank you so much. I mean, you bring up a huge issue we hear a lot from community residents. Our monitors are sort of these sensors, so they're not able to capture anything specifically about these odorants. But I'd be happy to talk to anyone that has ideas about how to do that. There's not a lot of permitting of this, so essentially the data we have comes from community members that have taken pictures of the trucks with their kind of IDs on it, so we can understand what chemicals are being used and we can look them up. But because it may change over time, I haven't thought of a good way to really try to better monitor for that, but I'd love to hear other folks' ideas.
Susan Hurley from EHIP. Thank you for a really interesting talk. I was curious about that last slide where you presented those results about the metals and toenails. I don't know if we really have time to get into it today, but if you could just tell me a little bit more about that and how you figured out which particular metals were associated with the various sources.
Yeah, so we use non-negative matrix factorization to identify sort of groupings. And that's sort of a unsupervised technique that looks at how these metals may cluster together among the participants we have. And then it's really relying on existing literature to try to identify where these metals may be coming from. And there has been particularly work among occupational oil cleanup workers that has also seen this nickel manganese mixture and use that as sort of an indicator, right, of high levels of exposure to oil workers. Also an analysis that's been done of PM filters near drill sites. They also see elevated levels of nickel and manganese. So it's still preliminary and sort of has helped generate hypothesis, but I think, it's very exploratory at this point and is something we're continuing to work on.
Hi, this is Martha Sandy with OEHA. Thank you for your talk. I read your publication, your paper on these the toenail study, the first one, and it looks like your methods are. I wondered if you could say a little more about the methods. It looks like you've washed the toenails clippings quite a bit, but I just it occurred to me: do you have any information or data on? After all that washing, are you pretty confident that any trace metals that might have been in nail polish, for instance, they have not penetrated and bound to the nail itself?
Yeah, so we asked the participant to remove nail polish before doing the clippings. That's just with these like wipes, so it may not completely remove it. This work is done by Brian Jackson at Dartmouth. So he's the expert on the laboratory methods. I do not do that. He's been doing this for a long time. And so I think he uses state-of-the-art methods, but I think, there's always potential for residual contamination or potentially, from nail polish. I think we try to clean it the best we can. But because, a lot of folks in the study, a lot of women frequently get pedicures, there's potential for that to be there as well.
Actually, I have a question. Stephanie Jarmal from OEHA. Could you talk a little bit more about why you chose toenails as a biomonitoring program? We're obviously very interested in many matrices, and just if you could say a little bit more about that.
Yeah, so I would say a big part of it was convenience and also comfort of the community in providing samples. And then also some limitations when COVID hit, right, of what was easier to collect and store. And so that was some of the initial factors we decided to work on toenails at first. We've had a lot of conversations to think about what we could measure with either urine or blood. And, I'm really interested to learn more from others around what could potentially be a good biomarker that could connect it back to like this crude oil signal.
Thanks. This is Dave Edwards from OEHA as well. Just to kind of follow up on Stephanie's question, I guess, did you consider hair? Before OEHA, I was doing some research and we did sort of metals in hair analysis, and just sort of wondering if that's better or worse than toenails. Just sort of a question.
Yeah, my understanding is that toenails are sort of reflect a longer integration, so it's more about 9 to 12 months, whereas hair may be more recent and also can be impacted by things like hair dye. And sometimes people don't, even if it's in the back, don't want to cut their hair. But I know there's been work out of Canada near it's natural gas fracking sites, and they have used hair as a biomarker, looking at various metals as well. So I think it's something that can be explored more.
Could you say something about how much the metals are what you're concerned about? That is, among all the large selection of toxics that are associated with these with oil and gas production. How big are the metals? How big a component is the metals, and what other substances are you looking at?
Yeah, I mean, I would say largely the concerns are around VOCs, especially the more toxic ones, both in terms of what we've seen with air monitoring, and I think in at least the urban environment, right? Air may be a really important pathway about how kind of exposures are impacting people's health. The use of toenails and metals was just a little bit exploratory, something we were interested in and had been kind of working at on a couple other sites. But do I think it's like the ideal matrix or chemical to be looking at? Like, probably not. I just sort of wanted to, since this was biomonitoring, sort of share it with this group to, you know, see some of the work that we've done. But I think VOCs are definitely more of a concern.
Thank you so much for that presentation and for all of the work that you're doing. It was wonderful to hear about it. Assuming there aren't any other questions, it's time for us to move on. And I want to introduce Yan Lin, who received his PhD from UCLA in 2019 with training in analytical chemistry, biomarkers, and biostatistics. Currently, he's a postdoctoral associate at Duke University's Global Health Institute and is on track to become an assistant research professor at Duke's Nicholas School of the Environment. His research builds on efforts to discover novel exposure biomarkers that are more sensitive and specific to emerging pollution sources, such as wildfire, smoke, and oil and gas activities, and identify key signaling pathways that mediate the health effects of air pollution and climate change. Today, he'll be presenting on urinary metabolites of polycyclic aromatic hydrocarbon derivatives as exposure biomarkers of air pollution sources.
Thanks for the nice introduction. Let me share my screen first. First, I want to say good afternoon to everyone, and I'm very happy to have this opportunity to share our recent finding about the source-specific exposure biomarker. First of all, I'd like to declare no conflict of interest associated with my research and specifically for this presentation. Well, I want to first talk a little bit about exposure biomarker. By definition, among different biomarker, exposure biomarker refer to the amount of xenobiotic substance or its metabolites in biological system and examples. So from this definition, we can clearly see that exposure biomarker is good to assess exposure for single chemicals, which pose significant challenge for air pollution exposure assessment because air pollution in nature is a chemical mixture. So before we really use biomarker for air pollution studies, we really need to identify important chemicals that are sensitive to air pollution changes as well as can directly inform the health effects of air pollution. For this purpose, we specifically focus more about the polyaromatic hydrocarbons for a couple of reasons. First, PAH their sources are also common pollution sources of air pollution, like combustion sources of vehicle emission, as well as no combustion sources like a lot of petrogenic sources. On the other hand, pH are also semi-volatile chemicals that can exist in both gas and particulate phase. So their atmosphere transportation is very similar to those of important particulate matters and also gas phase air pollutant like nitrogen dioxide. More importantly, substantial evidence that derive from toxicological and epidemiological studies has identified pH as the major toxic components of air pollution mixture. So the Explorer assessment of pH as a key toxic components of air pollution can directly inform its health effects. So for now, we have pretty good Explorer biomarker. I call traditional Explorer biomarkers for pH. That is urinary hydroxylated pH. For hydroxylated pH, it quantifies the total amount of unsubstituted pH that derive from almost all the combustion sources. However, as we can see in this diagram, most regulatory policy and interventional actions mainly target at the source, or in other words, emission of the pollution, so that any result deriving from hydroxy pH can really directly inform information about the source or emission of the pollutant in the air quality in the ambient air. So given this situation, we come up with the idea to develop source-specific Explorer biomarkers that can direct link pollution sources to health effects. So if this biomarker become available, the findings from this biomarker can directly inform regulatory policy or intervention that target at sources to mitigate the health effects. So our efforts to identify those biomarkers has greatly benefited from our early works about the source apportionment of ambient air pollutant. In those work, we have conduct large field campaign in North China and quantify more than 50 pH as well as some well-recognized source tracers in particulate matter samples and air samples. So based on the source apportionment result, we have identified several pH that are good tracers for specific sources. For example, we have shown that 2-methylated phenanthrene are good tracers for pathogenic sources, where we also identify other good tracers like 1-nitropyrin for diesel exhaust, 2-nitropyrin for secondary formation, and also some methylated pH as retain as good markers for wildfire. So because even if we have, although we have conduct research for all these different sources, in today's presentation, I will specifically focus on these pathogenic sources given the general interest in gas and oil-related emissions in this panel. Our study leveraged some natural contrast in the air pollution conditions at different locations to validate markers. Here we mainly talk about two megacities in the world. One is Los Angeles, one is Beijing. I hate to say this, but I think both cities are very famous for its severe air pollution. But as shown in this slides, the nature of air pollution in those two cities are very different. First, the level of air pollution is dramatically higher in Beijing as compared with Los Angeles, as indicated by those ambient PM 2.5 level. There are at least a 5-fold difference in the level of air pollution. On the other hand, the source of air pollution is also different between the two cities. In Beijing, almost all the pollution sources are combustion related, like vehicle, coal burning, and biomass burning. Well, for Los Angeles, in addition to those substantial pathogenic sources like a vehicle emission, there's also a lot of pathogenic sources like oil and gas drilling. So those natural contrasts in the Air Pollution Explorer provide a perfect opportunity for us to identify Explorer biomarkers. Our study is built upon a very unique cohort who travels between the two cities in the summer in each year. At UCLA, there will be a summer exchange program between UCLA and Peking University in Beijing, in which around 10 to 15 students from UCLA will travel to Beijing and stay there for 10 weeks. So what we did is we tried to recruit a student and collect their urine samples before, during, and after their travel to Beijing. We conducted this study for multiple years so that we can also study the temporal trend of exposure over years. This figure shows the level of ambient PM 2.5 during the study period. In this each panel indicates the data in each year, and the green dot here indicates data in Beijing, while the white dot indicates the data in Los Angeles. As we can see, across different years, the level of PM2.5 is consistently higher in Beijing. Well, if we look into those green dots only, the level of PM2.5 continues decline over years. This is because since 2013, there is a very ambitious air pollution control measures implemented in China. So we can see the effects of PM2.5 level here. So from the urine collected from the subject, we have measured different explorer biomarker in the urine. Specifically for PAH, we first quantify the level of hydroxy PAH. We know the beauty and also the limitation of explorer biomarker is that it's quantify the exposure from almost all the routes, including inhalation as well as dietary sources and other no air pollution sources. I want to mention that in this study, we have actively controlled no air pollution sources using experimental control. For example, for smoking, we have excluded all the smokers from the study so that smoking is not a major influence factor here. We cannot fully exclude the effects of secondhand smoke, which is likely to be higher in China due to the higher smoking prevalence. However, we measured urinary creatinine to post-hoc assess their secondhand smoke exposure. We know diet is another important source of PAH, and especially for urinary biomarker, with short time, I think recent diet will also make important contributions. So in our study, we have minimized the effects of dietary sources by collecting morning urine samples after at least fasting for 8 hours. In addition, we also use questionnaire to collect important information about their important dietary sources like barbecue intake. So this result shows the level of total urinary pH metabolites among the study participants. Again, the green box here indicated data in Beijing, while the white box indicate data in Los Angeles. We can see clearly across different years, traveling from Los Angeles to Beijing significantly increased the level of pH metabolites, while returning to Los Angeles, will making those the increase go back to baseline. And also, if we focus on green box only, we can see a continuous decline of the pH metabolites in the urine over years, which is perfectly consistent with the trend of ambient PM2.5 level. We also conduct association analysis between urinary pH metabolites and ambient air pollution levels, and we found that pH exposure markers were significantly associated with ambient NO2 and PM2.5 concentrations. So taken together, this result suggests that hydroxylated PAH can perfectly capture the variability of air pollution exposure. Now that we have a good tools to assess air pollution levels, what about source? We also, in addition to the air pollution levels, we also mentioned that the Los Angeles has very unique pollution sources like petrogenic sources, as indicated by this news headline. So about 1/3 of the population in Los Angeles will potentially exposed to petrogenic sources. So whether we have biomarker that can capture those changes in sources. Here we use hypothesis-driven and focus on a particular hypothetical tracers for petrogenic sources to methylated phenylalanine. Based on previous literature, we have found that this chemical was more abundant in the petrogenic sources, while their abundance is quite low in combustion sources. I think a likely explanation is that the combustion sources will generate a highly oxidative environment that could oxidize the methyl group in this methylated PAH and therefore consume this chemical. And also based on the previous literature, especially those from environmental monitoring studies, we can find that the ratio of 2-methylated phenylalanine to phenylalanine was generally higher among environmental metrics that came from petrogenic sources. So then we think about if we can also quantify the metabolites of methylated phenanthrin and phenanthrin in the urine, we can potentially extend those diagnostic ratio from environmental samples into the biomonitoring studies as a diagnostic ratio to distinguish pathogenic versus paragenic sources. The good thing is we already have a good markers for phenanthrin, which is a hydroxyphenanthrin. However, at that time, there's no biomarker that were specific to methylated pH. Then we try to develop a method to measure urinary metabolites of a methylated pH. And the first step is to identify what's the metabolites of a methylated pH in human body. And from one in vivo study based on human liver microsome, we have identified such a biotransformation procedure. We have found that for the methylated phenanthrin, the metabolism mainly goes through side chain oxidation, and the final product is a carboxylic acid metabolite of phenanthrin. However, at that time, it's not known whether this chemical exists in human urine. Therefore, we have leveraged our strengths and develop an analytical chemistry method and successfully identify those two carboxylic acid metabolites of phenanthrin in the urine. As we can see, the signal is pretty strong in all the urines as indicated by this chromatogram. Using this method, we have successfully detected these chemicals in more than 90 urine samples, in more than 90% of the urine samples we have collected from the travelers. And this figure shows that the spatial differences in traditional marker, hydroxyphenanthrin, and also our novel markers between Beijing and Los Angeles. As we can see, for both markers, there are significant increase in Beijing, which is consistent with more severe air pollution in Beijing, and also demonstrate this novel marker is also sensitive to changes in air pollution levels. Further on, we have calculated the metabolites ratio between carboxylic and hydroxy metabolites of phenanthrin, which is a hypothetical diagnostic ratio of pathogenic sources. And we also found this ratio is quite sensitive to changes in the environment. As we can see, traveling from Los Angeles to Beijing significantly decreased the ratio. While returning to Los Angeles will make it go back to baseline. And also the higher level of this ratio also indicate higher contribution of pathogenic sources to the overall exposure. So this evidence provide indirect evidence showing that our markers could potentially used to quantify, to estimate the relative contribution of pathogenic versus paragenic sources. Further on, leverage the data from multiple years. We have also explored whether there were significant temporal trend of those ratios across different years. And we can see in both Los Angeles and Beijing, this ratio was significant increase from 2014 to 2017. In Beijing, because we have pretty source approximate result, we know that this increase in the ratio is mainly driven by the reduction in combustion sources or other word paragenic sources. However, we have no comparable information in Los Angeles, so we don't know whether it's the change of pathogenic versus pathogenic, which one drives this temporal trend. But I think an interesting observation is that the increasing rate of this ratio in Los Angeles is higher than that of Beijing, which implies that maybe both the reduction in paragenic sources and the increase in pathogenic sources can make a difference here. I think so. After this study, we still have a lot of unanswered questions. First, in the Beijing Los Angeles study, we didn't collect any information in the air, so we don't know whether those metabolites in the urine can reflect air pollution exposure. On the other hand, we also, as shown before, the biotransformation procedure can also influence the biomarker concentration in addition to the exposure itself. So that's why we conduct another study to further testing those two questions and see whether whether external exposure to methylated phenylalanine can contribute to urinary carboxylic acid metabolized phenylalanine, and whether the ratio in personal PM2.5 sampler are correlated with their hypothetical metabolite ratio in the urine. In this study, we have recruited 120 adults in Beijing and repeatedly collect their personal PM2.5 samples and match the urine samples. So the association analysis was conducted to test those hypotheses. So this figure shows the correlation between the personal exposure and urinary metabolites. The figure on the left indicates there will be positive correlations between personal exposure to PM2.5 bound to methylated phenylalanine and urinary 2-carboxylic acid metabolized phenylalanine. Well, the figure on the right indicates there is a positive association between the ratio in the personal PM2.5 samples versus those in the urine. So this evidence provides direct support that the metabolites changes in the urine can directly resulting from the changes in the ambient inhalation exposure to PAH. And also in Beijing, I think there is a huge seasonal differences in the nature of air pollution because of the heating activities. In Beijing, the major pollution sources in the non-heating seasons are traffic emission, while the major pollution sources in the heating seasons are coal and the biomass burning. So that's why we stratified the data based on season and test whether the positive association was robust between the two seasons. And our results suggest that the relationship between ambient PAH and the urinary metabolites could be changed at different time, along with different seasons with different pollution sources, which means exposure is not the only predictor of urinary metabolites. Therefore, we have also additional collect a couple of questionnaire data and see whether any other factors can influence the level of 2-carboxylic acid metabolites in the urine. And here we have identified two important factors that can influence the metabolite concentration. The first is the smoking history, and the second is alcohol consumption. Based on literature, we found that those two factors are also modulators of the biotransformation of 2-methylated phenylalanine to carboxylic acid metabolites of phenylalanine. Specifically, smoking can directly can change the activity of cytochrome P450, which is responsible for the first oxidation of side chain. Well, the alcohol are also substrate of those ADH and ADHL, so that the alcohol can compete with the 2-methylated phenylalanine in the metabolism, and therefore can also influence the concentration of their urinary metabolites. So for now, we have let's provide a brief summary about what we have, the information we have gathered so far about those novel biomarkers. First, we have provided direct evidence showing that the urinary metabolites, urinary carboxylic acid metabolites of pH are mainly derived from methylated pH. And also because methylated pH is more abundant in the pathogenic sources, the ratio between carboxylic acid and hydroxy pH can be used as a diagnostic ratio to estimate the relative importance of pathogenic sources versus pathogenic sources. In addition, we have identified two important lifestyle factors, tobacco smoke and alcohol, as important modulate influencing factors of the level of those novel biomarkers. So we recommend to collect those two information in future population studies to better control the effects of lifestyles on the biotransformation procedure. I think I'd like to acknowledge extensive help from our collaborator at Peking University, UCL, and Duke, and also I want to acknowledge funding from multiple funding sources, including NIH. Thanks a lot for your attention, and I'm happy to take any questions.
Thanks so much. So similar to last time, we'll have both a chance for questions and then an open public comment period, and then a discussion, a longer time for discussion. So we'll start with questions from the panel or from the audience about this talk. And we also have someone monitoring online. So if there's a webinar attendee who wants to ask a question, feel free. It's a very thorough presentation. Okay, one question here.
Yeah, thank you for that presentation. It's very interesting. I think it seems that one of the things that's really also demonstrated by your presentation that I was struck by is how much overlap there is between these, different biomarkers. So, and which obviously relates to the fact that people are exposed to PAHs via so many different routes, multiple different routes, right? And I was wondering, how teasing out the relative contributions of each of those sources, even with these biomarkers is very challenging. I was wondering if you could comment on that some more.
Yeah, thank you. That's a really nice question. I think for biomarker, I think for the recommendation of the use of biomarker, we have, I think there will be two scenarios. I think one scenario is that we use biomarker to quantify the total amount of exposure and to understand where this exposure came from. Like, in this way, we can try to understand whether dietary sources are more important or inhalation sources are more important. If this is the purpose, I think we can just go ahead and collect convenient urine samples for the measurement of a biomarker, and also link them to different exposure route that can better understand where this chemical came from. And another a scenario that we want to use biomarker is we employ it as a tool for us to assess specific sources. In this way, I think definitely air pollution if air pollution is something we want to study, we really want to do something to minimize the effects of other sources like dietary and like smoking. So if this is the case, I would recommend we do more experimental control or provide guidance to the subject who will donate the urine to avoid getting exposed from other sources. In this way, the result can be directly used to inform to what extent they were influenced by sources. So that's will direct to different purpose of the markers and will rely on different study design.
So I could check for, oh, we have another question. Sorry, Kathleen.
I might have a question online too.
And sorry, I'm right behind you with the camera. My question is around the sort of relative half-lives. If you're thinking about exposure, like trying to diagnose exposures from one source versus another source, and whether you have a recommendation on sort of how many samples you would want to take per person to sort of get an idea about perpetual exposures, because diet can change from one day to the next, and that would definitely impact your PAH levels.
I think that's a really challenging question, and to be honest, I don't have a direct idea about the sample size we will require to get that one. But I think some information we can share is that we do find those biomarker has pretty it's less influenced by those genetic factors like who you are, so that we don't rely on like a super longitudinal design to control to make subject has their own control, and this marker can be good used for cross-sectional study. I think the sample size is really depends on the strength of the exposure. Like if you have a huge exposure from like a gas or oil drilling, I think definitely a small sample size will be adequate. But if the signal or the contribution of gas and the source of interest is a relatively minor or moderate source compared with other sources, definitely will have a larger sample size in order to detect a difference.
We had a question from Jose.
Yeah, hi, yeah, very interesting presentation. I really enjoyed the part where you're including students to be part of your subjects there and these time trend visits, and looking at how that really, how the different methods that you're using is sensitive enough to stratify and detect the differences in these exposure levels. So just a question: for example, you have some of the VOCs here, the methyl, what is it, PHE versus the non-methylated versions. What are the half-life differences in the body versus in the environment, in the air? And linked to that, of course, would be how much within individual variability would you expect versus like a between individual variability? And the third question, which is also linked to that, so kind of how wide of an exposure window is the measurement giving us?
Yeah, thank you. All these are really nice questions. So let me answer the first question. I think it's about the biological half-time. I think there will be direct evidence to support that for the hydroxy pH, the half-time is around 10 hours. And there will be, for now, there is no much information about biological half-time of those novel markers, the carboxylic acid pH. But we do conduct a preliminary test about 10 subjects that weeks exposed to extremely high level of air pollution. I think our preliminary data indicate that the half-time of carboxylic acid metabolites also within 24 hours. Which means I think for both markers, they are pretty short term. And I think that's also consistent with the fact that there's a good amount of both biomarker in the urine. So so in this case, I think definitely the exposure window for this marker will be around recent 1 to 0 days, something like that. And also for the half-time of pH in the atmosphere, I think it depends on the phase. Like if the pH exists in the gas phase, I think they're also short half-time because the solar radiation can provide a very strong force for them to degrade, and also some atmosphere oxidant like free radicals can also break down those pH. But if those pH was bound to particles, I think they can be pretty persistent because some other suit can cover the surface of particle matters that can prevent the degradation of those pH. So it really depends on whether they exist in the gas and the particles. Sorry, Meg, could you repeat the question, the second or the third question?
No, I think you got it. So I guess the second one was more looking at within individual variability versus like between individual variability, which typically tends to be very related to the half-life of what it is that you're measuring.
Yeah. Thank you.
Thank you.
Mm-hmm.
Yeah, Amy.
Thanks so much. This is a really interesting study design. I was also wondering if you have considered testing even, especially within the LA time during LA, when in between times when maybe there'd be more petrogenic sources versus times when wildfire smoke might dominate the air pollution, and whether you could see the patterns between those two periods. Yeah, that's my first question.
Yeah, that's a really nice question, and also the short answer is we do consider about that, but I think our example is not ideal to answer that question because because our study cohort, like UCL student, is highly clustered. Almost all of them was a resident in the nearby UCLA, so that near UCLA, so that there will be a lack of spatial variability in those sources. And also for all the collection, we have conduct in a narrow time window in either just before and after the summer. So we also lack of a good temporal coverage to capture those wildfire episodes. So we hope we can have opportunity to have a better temporal or spatial coverage, probably in future study among Los Angeles residents to capture that wildfire episode on those biomarkers.
I need to check in about public comment and then we'll move on to the discussion. Rebecca, is there something? No, okay. In that case, we have just under half an hour for a discussion of this topic that both presenters contributed to. And to get the conversation started, I want to read a series of questions that the program has provided that touch on questions that are coming to them as they consider how to study this topic. So when conducting a biomonitoring study around oil and gas exposures, there's a few issues that the program would love to have us weigh in on, and then any other discussion points that anyone wants to bring up are fine too. So the first is the program is aware of heavy metals, PAHs, and VOCs as analytes of interest in communities living near oil and gas fields. Are there any additional analytes that the program should consider? The second one is, does the panel have any recommendations on assessing cumulative impacts, particularly when interpreting results and discussing results with participants? The third is, we heard today that LA County communities are heavily impacted by exposure to toxics from oil and gas activities. Are there additional communities or areas in California that the program should consider biomonitoring for oil and gas exposures? And finally, are there any gaps in the literature that the program should consider or further research that's needed before initiating a biomonitoring study in these communities? I can refer back to those. I think you're trying to bring them up. So they might be on the screen soon, but also we can refer back to them as needed. Anyway, if that sparks discussion, it sounds like those are priorities for the program and beyond that. Oliver.
Yeah, hi. Oliver Fien, UC Davis. I was happy or lucky to collaborate with Hyun Lin on the cumulative impacts on the exposures that he just presented. He did not talk about it, but if, I may paraphrase, we look at the cumulative impacts on both oxidative and or inflammatory and anti-inflammatory results in plasma from these people, as well as triacylglycerides. So we saw very clear differences in metabolic impacts in the studied participants as, let's say, associated with the exposures, but with the same study design. And therefore, I think it might be good to look at those things as well in other exposure studies, not just exposure, but also how does it change and significantly change in body fluids of participants.
Other comments on or discussion points on these topics or others related to initiating a biomonitoring study of oil and gas exposures, exposed communities?
Just a quick question here as a follow-up to Oliver's comment there. Are you thinking more of something a little bit more mechanistic, like the short-term effects of these different on maybe like a subacute effect, or maybe even a very acute effect of the different concentrations in serum or whatever biospecimen urine in relation to inflammation markers, triglycerides? Is that what you were trying to get at?
Yeah, in a way, that's I think important at the end of the day, not just to know what we are exposed to and how much, but also how it affects the body. And there are methods today that, there can be different methods used, obviously, to assess that. But I think, particularly to the number 2, right, that is a cumulative impact. And when you go back to participants and say, well, we have that, and we also have information how it may change a specific metabolites that have impact on health. And these are so-called lipid mediators that we measured with Dr. Yanlin. And so that might be also informative for participants. They might want to know that, right? And so that was a unique study where both of that could be investigated. And I just happened to know it because I was partnering in that study. But I, could imagine that this type of analysis and maybe other types of markers might be informative in terms of what does it mean to be exposed to something.
I have a question that's maybe for program staff or other people who are more aware of the research in this area than I am. As you contemplate a study, is the comparison community generally people it's all about proximity to the production? So you're comparing people who are closer, living or working closer to it than people who are farther away, but in the same region. I think that's how most of these studies are done around oil and gas exposures. And I'm wondering how folks who've already worked in this area manage the issues of location of work and an occupation, and how that might do exposure misclassification comes in with those questions. How is that generally controlled in these kinds of studies? Any thoughts on that?
I guess I can say a little bit about that. Stephanie Jarmel from OEHA. I believe it's 1 kilometer is considered living near an oil and gas facility. One of the studies also out of UCLA, I believe, used that as their parameter. And I think it depends on what your question in terms of who your control population is. Because, LA is a very unique situation, but there might be some other communities in California who would have different variety of exposure sources. And even with Ian's presentation, we're really interested in that because that might at least give us the opportunity to help distinguish between the petrogenic and the pyrogenic sources. So being able to tease out, are these exposures coming from their proximity to oil and gas, or is it from nearby traffic? Because that also obviously heavily impacts LA. So would we want to control a population that is further away from traffic sources and just near oil and gas facilities? These are all questions that we're kind of pondering.
And what about location of work and what work folks do?
You mean what type of work they do or the location of their work itself?
Both, actually, but I'm thinking for such a location-based study, you need to know where
Right.
people go during the day.
And that is something we can consider. We did that for EBDEP, I believe. We did we maybe even had a tracker that they wore to sort of track where they were going on each day that they were involved in the study. And so I think we're actually working through some of that data right now and how best to, if we were interested in doing that in the future.
Another thought, and I don't know this literature super well, but I know you do because you use this, is silicone wristbands as a way of helping stratify exposure groups. And you don't have to know so much about where they went, because if you have this sort of passive monitoring method to sort people, if you know that the petrogenic sources travel with something that you can measure in a silicone wristband. I'm getting a little vague here, but as a concept.
That is certainly something we're interested in. I'm not as clear if pHs themselves, what their absorption rate would essentially be in the wristbands. We are just now working through our very initial pilot testing of the wristbands for the Fresca study. So we're hoping to learn more a bit about that, but that is definitely something we're interested in pursuing in further studies. I know they've been used in many studies and have had promising results. but I'm not as clear with the pHs specifically in the silicone wristbands.
Yeah, I think I can add some information about the pH in the wristband. And actually, we do have some experience in measuring pH in the wristband. I think they are pretty good in getting us a result. Like if we wear a wristband for around 1 day, and in a typical situation, we can get good amount of pH. But most of the pH we can detect is just 2, 3, and 4 rings pH. And for those heavy ring pH like a BAP, they are typically not detectable for wristband. So that's some information we can share.
Hi, this is Susan Hurley from EHIB. I was just thinking back to one of the comments that Jill made in her presentation, which was, I think it was in the South LA study where you mentioned that the air toxic levels went down when the drilling stopped. And so that you could see that even in a community where there's a lot of traffic. And so I'm thinking, is there any way to design a study that takes advantage of that? Like, are there planned like times of non-operation, given that a lot of these biomarkers have short half-lives? I'm wondering if, we could design something around that. I don't know enough about gas and oil development to know if that's even a possibility.
With that, I think there's some wells that are planning to sort of phase out production, at least in LA County. I'm not sure about Kern County, but I mean, that's sort of what we leverage, right? To look at when the well was producing versus when it went idle. And so, I think there's potential to leverage those opportunities as it's anticipated, like more wells are gonna stop producing, over the coming decades in LA, to try to examine those changes. I think one other thing to keep in mind, there's other issues, is just there's really different control technologies used on different well sites in LA. And so, in that case, the exposures may not all be equal depending on sort of what neighborhood you're looking at. And so that hasn't really been fully explored. And there's been air monitoring studies around Baldwin Hills, and then one that's gonna start in the Las Ciénegas oil field, so the South LA oil field. And then there's been some work out in Kern County as well. And that could potentially offer insights as they measured a whole large suite of VOCs.
I had a question about other factors affecting indoor air quality, because if we're looking at residents and residential proximity, then there's so much variation in indoor air quality and the factors that affect it. And, I know in the studies that the program's working on around wildfire smoke exposure and interventions, there's also just this, use of indoor air purifiers and different types of indoor air purifiers as an intervention arm of the study. I just raised it as a point of consideration with this, either as an element of the study or how to account for differences in people who may be living within a kilometer of the oil and gas extraction site, but may have very different factors affecting their indoor air quality, like air purifiers, and how you might incorporate that into questionnaires to make sure it's not mixing groups.
I think we would definitely want to include questions around that in our surveys of participants. And luckily, we have a lot of those questions already from our previous studies. That's always a big concern, is these other sources of exposures, indoors especially. So yes, that is something we will make sure that we look into. And then I'm also, I believe, maybe Jill knows a little bit more about this. I thought there was some legislation that was introduced to reduce maybe emissions in, I don't know if it was LA County. I don't know, Jill, if you're familiar with this in the next few years, having to deal with the different proximities to the oil fields. And that might be something interesting to look at too, if we're able to, I'm not sure of the timeline, if we're able to get out there before and after. That's something else we can consider.
Okay, so in last year, LA City and LA County passed a phase out. Right now it's about a 20-year phase out for oil and gas drilling. It was declared incompatible land use. Most of the wells that go offline are sort of individual ones. So they happen as a result of lawsuits or as well as a result of like added permitting requirements on them that may change, right, what kind of control technology is being used. The statewide legislation was the 3,200 foot one, but that hasn't been implemented yet.
I don't know the details of it, but there is a bill, Nancy Biermeyer, Breast Cancer Prevention Partners, about idle wells and capping idle wells. That's pending now. I'm sorry, I don't know more than that, but.
Did you have something, Amy, please?
I had a few comments to sort of follow up on a few threads that have been going. But one was, yeah, there have been other studies similar to Jill's by David Gonzalez and others on oil wells that have closed, and then the changes specifically in air pollution. And I think that also just brings up, I think I was struck when I was reviewing some of this work is that about just the cumulative exposures. So it's not, I think, as important as it is to kind of find out what's really coming from the well itself, but also the trucks that bring the oil and all of these other kind of additional pieces. I think if there's a way of kind of creating metrics that account for the cumulative nature of them. And then also I agree about the importance of understanding infiltration of these pollutants into the indoor air. And I think in addition to air purifiers would be information on air cooling systems, whether they're filtered or not in that process, especially in LA, given the heat considerations. So yeah, in addition to kind of other housing factors, cooling would be something I'd want to include.
And Jose?
Yeah, this question is for Jill. And first, Jill, thank you for that presentation and the wonderful work. I would like to disclose that in my graduate level course of environmental and occupational health at UCSD, we use one of your publications, the 2021 about respiratory health, as a case study, and students love hearing about it. It's an eye-opener for a lot of people to realize that there's so many oil wells within LA proper. Today we've been hearing about PFAS as well. And I know that PFAS have been measured in air in large manufacturing plants in general. What do you know about the use of PFAS for oil extraction?
Not very much. I have been told it's used, especially like in drilling fluids when they do injections with PFAS, but I have not kind of studied it or analyzed it in any way. So sorry, I can't be more useful. But yes, thank you for your comments.
Any other comments or points of discussion on this before we go to an open public comment period on all the content from today?
We do have a member of the public that would like to speak. I'm not sure if it's for this item or for the open public comment period, but Dr. Samchai, if you wanted to unmute and speak.
Dr. Ahimsa Porter-Samchai. I am the founder and the director of the Hunters Point Community Biomonitoring program, the foundation, and the Toxic Registry. With regard to the item on the agenda, I just wanted to point out that the Richmond Martinez area of Northern California is an area where there's a heavy concentration of refineries. And also point out that there was legislation that was proposed that would create buffer zones around oil and gas refineries, specifically those that are sited near daycare centers. I wanted to speak very, very briefly about the findings of the 5-year Hunters Point Community Biomonitoring Program and our creation of a toxic registry. The Hunters Point Biomonitoring program was launched in January of 2019, and we use a kit that is capable of detecting 35 potential toxicants, including chemicals of concern documented to be present at a federal Superfund site, in addition to chemicals that are listed on the Proposition 65 list of carcinogens and chemicals that cause reproductive harm. In the 5 years since we have launched, we have been able to geospatially map a community within the 1 mile perimeter of a system of federal Superfund sites. And our findings identify basically that the risk of exposure is factored by 2 parameters: how close you live to the base, and how long, the duration of exposure. Most of the people who we have entered into the registry consists of 100 people, 85 residents, the majority of whom currently live within the half-mile perimeter of the federal Superfund system, and 15 UCSF workers, current and former, who are located on the naval base within 200 feet of a landfill. And of that group of 100 people, that cohort, all of them have risk of exposure, evidence or proof of exposure, and adverse health effects. The chemicals that we are detecting are chemicals that are documented by the EPA and the Navy to be present in soils at the federal Superfund system, as well as chemicals on the Proposition 65 list. The most commonly detected chemicals above reference range are manganese, vanadium, thallium, nickel, gadolinium, rubidium, arsenic, and then we have chemicals on the Proposition 65 list, including lead and chromium, cadmium, vanadium, and radionuclides. We have also conducted speciated urinary screenings capable of detecting radioisotopes, and we have detected radioactive potassium, a progeny of plutonium, as well as a progeny of uranium and cesium. So we are working right now to formalize the registry to develop the type of funding that it needs for advocacy and protecting people who are currently living and working within the 1 mile perimeter of the federal Superfund system. Thank you very much.
Thank you for that. Is there any other public comment?
Hi, Shoba Iyer, San Francisco Environment Department, and previously a toxicologist at OEHA working on biomonitoring California. I have a couple of comments I want to make that could be suggestions for a couple of the questions. Some of you might remember that I shared information about quaternary ammonium compounds in years past, and they are a chemical class on both the designated and priority chemicals list. When I was looking at potential for exposure to these compounds, I did see that there are quaternary ammonium compounds used as oil field biocides and corrosion inhibitors in oil and gas operations. So that might be a chemical class to consider in terms of an analyte. And then in that research I had done, I was collaborating with an OEHA colleague who's familiar with a database of chemicals used in fracking and oil and gas operations that I think at the time was housed by DOGGR. It's an acronym, a state acronym. I don't remember what it is. And now I think it might be the Department of Conservation, but there could be other state resources for looking at what other potential analytes might be to evaluate, as well as locations of oil and gas wells.
Any other final comments or anything on the web? Web attendees. In that case, we can wrap up the meeting. I should announce there will be a transcript of the meeting posted on the Biomonitoring California website when it's available. And the next SGP meeting will take place on July 19th, 2024 from 10 a.m. to 4 p.m. And options for attending that meeting will become clear as the date approaches, and will be posted on the website or sent out to the mailing list. Biomonitoring California will, as you've heard, hold a 15-year anniversary celebration upon adjournment of the meeting. And I want to thank, as usual, the staff for putting together an amazing meeting, and the audience, and of course the panel members as well, and adjourn the meeting.